Next, I want to talk to you about the CloudFormation template anatomy. This is where we're going to break the template down into its various components. Now, this is quite in-depth, so I want you to obviously just understand a little bit about the different aspects and the different components of the anatomy, and we'll play around with it when we get on into further labs later in this course. So the first element of the anatomy is the template version. Now, we've covered this already in our previous videos. You saw that the template version is basically identifying the capabilities of the template. And the latest version format is 2010-09-09 and is currently the only valid value. So it looks like this. In JSON, that's how you'd present it. In YAML, it would just be AWS TemplateFormatVersion, space, and then in speech marks, quotation marks, 2010-09-09. It's as simple as that. Next, we have description, which is an optional component, but it's really best practice to include a description for your template so your colleagues and clients know exactly what the template is supposed to be doing. So the description section enables you to include comments about your template, and the description must follow the AWS TemplateFormatVersion section. And it simply is description : open greater than sign, and then the actual comment that you want to include as part of your description. And then we have metadata. Metadata is another optional component for your CloudFormation template and is used to store additional information like how the template should be displayed in the AWS console or with tools. So here is an example of a metadata where we are basically describing how the information should be displayed. And essentially, its purpose is a section of the template where you can attach basically extra information about the template or specific resources. It's not used for provisioning infrastructure itself, but rather for adding documentation or descriptive information, controlling how resources and parameters appear in the AWS console, such as UI hints, and passing data to other AWS tools like CFN in it. Next, we have something called parameters. Now, the parameters section is where you can get user input. You can define default values for various properties and then have users input their values if they want to modify the template before it's deployed in a particular way for their specific use case. So it allows users to pass input values when creating and updating a stack, such as the instance size, key pair, that kind of thing. So if you take a look at the example here, the default for this template is to launch a T2 micro, but you might want to allow your users to be able to select other types of instance types. So T3 micro, T3 small, whatever the case might be. So if the user doesn't do anything, then the default deployment will have an EC2 instance of a T2 micro instance type. But giving these options under the allowed values section to the user allows for that flexibility. Parameters are optional as well. Next, we have mappings. Mappings is yet another optional element, but a very powerful component. It allows you to create lookup tables to map keys to values. For instance, we spoke about those AMI IDs per region. Now, in that example where we did the lab, you had to go into the AWS Management Console, check out the actual AMI ID, and then come back and update the template. You don't want to be doing that. When you're automating your deployments, you want CloudFormation to identify where it is getting deployed. So if it's getting deployed in the US East 1 region or in the EU West 2 region, and then accordingly look at a map of what available AMI IDs are there in that region, and then select one from there accordingly. So in this example, if this template is getting deployed in US East 1, then that's the AMI ID to use. Else, if it's getting deployed in AP South 1, then that's the AMI ID to use, that kind of thing. So it offers that flexibility for your templates. Then we have conditions. This is yet another optional component, but it adds the capability to deploy solutions and infrastructure based on certain conditions that are being met. So control whether certain resources are created based on parameters. So based on the input values that the user provides, we can define whether a particular resource is created. So in this case, we're creating a prod resource if the environment that the user selects is prod, that kind of thing. Now, you can use various intrinsic functions to define your conditions, such as the and, equals, if, not, or statements. Then we have resources. This is the only required part of the actual template. Nevertheless, you, in most cases, are going to be using all of the other components as well, like parameters, for instance, or even mappings. But the resources is the only mandatory section. It defines the actual AWS resources that you want CloudFormation to create. So here we're defining a resource block. We're defining the name that we're assigning to the resource, the type, which tells CloudFormation what it is we actually want to create, and its properties, what AMI we want to use, what instance type we want to use, etc. You'll see here that we're actually referencing a parameter value called reference instance type. So somewhere up in the script, we're going to have a parameter that allows us to select that instance type. Remember, we saw under parameters, we defined instance type, and then we had those allowed values, that kind of thing. So it'll pick it up from there. So whatever the user selects, let's say the user selects T2 extra large, then the instance type is going to make a reference to that parameter value and inject it into this part of the script at runtime in order to deploy a T2 extra large instance type. Next, we have outputs, which is yet another optional component, but it returns useful information after the stack is created, like the load balancer URL or the IP address or the resource ID. And so the outputs allow you to define what outputs you want the CloudFormation template to present to you so that you can then take further action. And you will notice that there is one over here where we're trying to get the public IP of the instance, and we're using the getATT intrinsic function. So this function allows you to return values of an attribute from a resource in your template. And when you want to reference something about the resource that isn't just a logical name or ID, you can make use of the getATT function. So an EC2 instance has attributes like public IP, private DNS name, etc. You can essentially get them with the getATT function. So here we're saying getATT my EC2 instance, which is obviously the logical name of my instance, dot its public IP. So next we have the transform section of your CloudFormation template. Again, this is an optional section, but it's extremely powerful. So you can create macros that can perform simple tasks like finding and replacing text, or they may make more extensive transformation to your entire template. This basically tells AWS to pre-process or expand parts of the template before actually creating the resources. And so there is one particular type of CloudFormation transform called the AWS include, which essentially pulls in external template snippets from, say, an Amazon S3 bucket. So the example is to reuse a common security group config. So you're basically including a link to another YAML template that's stored in an S3 bucket to perform that particular part of the operation to build out your entire stack. Another one, really powerful one, is the AWS serverless transform. Now, this basically is the serverless application module transform that expands the shorthand syntax into a fully blown CloudFormation for several applications and apps like Lambda, API Gateway, and DynamoDB. It allows you to define Lambda and API Gateway endpoints in just a few lines of code rather than writing hundreds of lines of YAML. So the idea is you have your Lambda function, the code itself located somewhere, and you're basically pulling that across to transform it. So let's take a look at an example to see how that would work. So on the right, I've got a CloudFormation template that uses the transform, the serverless transform feature. So it's a simple serverless app that needs to be deployed with Lambda and API Gateway. So when it comes to the resource, we're basically specifying a Lambda function. So the type is AWS serverless function. We're defining the fact that we're creating an index handler, the runtime environment, and the code URI, or the location of the actual Lambda code. Okay, so that's written obviously in Python. So that is obviously critical. We're defining the memory size, the timeout, and all of that wonderful stuff. And so the transform line tells CloudFormation to use the SAM macro. And in this case, you've got obviously the serverless function that basically means that you're looking at a Lambda function. In the event section, we're defining an API event. So we're basically automatically creating an API gateway with, so the type is API, with the path to /hello. So that's the actual endpoint name, and the method we're defining there, which is the get method. So within this few lines of code, we are actually able to build out a complete serverless application stack as well. And if we were not using the transform, we would have to manually define an IAM role, API gateway resources and methods, and the Lambda permissions, etc. But we don't need to do that anymore. SAM takes care of building all of that out for us in the backend, and we're using the serverless transform module of our CloudFormation template to help us call that and build that out for us. Okay, now before we actually end this lecture, I just want to revisit the intrinsic functions that you should be aware of. So let's do that next. And so just to reiterate, the getATT is basically an intrinsic function where you can get the attribute of a particular resource. It will return a property, the attribute of a resource that CloudFormation has created. And so the example here is get the allocation ID of an elastic IP, which is the resource that is attached to your NAT gateway. And so if we take a look at how it looks on the actual code, then you will see it's NAT gateway. The type is a NAT gateway. The properties is which subnet we're putting it in. So here we are using a reference function to refer to the public subnet. I'll talk more about that in a second. But here is where we are saying we want to allocate the allocation ID of the NAT IP address. And so we need to get that first. So we need to fetch that allocation ID. So we're using the getATT intrinsic function of what? Of the NAT EIP. What of it? It's its allocation ID. Okay, so that's how that works. The next intrinsic function that I want to quickly talk to you about is the ref. Now, we've already taken a look at this multiple times earlier, but just to reiterate, the ref intrinsic function essentially refers to or references another resource or parameter. Now, it will either return the value of the parameter or the physical ID of the resource. So in this example down here, the ref my instance is returning the EC2 ID. Okay, so that's the actual instance ID. And the ref my ERP is returning the elastic IP address. So you saw that this is different from the getATT. With the getATT, you were getting the allocation ID. With the ref, you are just getting the actual IP address. Okay, in the case of EIP. So you need to understand these critical differences. And then finally, there's the find in map feature. So we spoke about mappings earlier, right? So in the mappings, you've got US East 1, use this AMI, EU West 2, use that AMI. How do we actually apply it in the code? And so in order to use this map, okay, that we have with our different AMIs for our different regions, wherever the CloudFormation template is being run, so say if it's being run in US East 1, then for the image ID, it's going to look at the map. So it's going to find in map, right? Which region we are running in. So it's going to look at the mapping name. So it's going to pick it up from this list over here from the map. It's going to identify the first key as the region. So, okay, we're in US East 1. So let's pick that up. So region where the stack is being deployed. And then the AMI that I need to use, which is the second key or the column to fetch in order to be able to ensure I'm picking the right AMI for that region. So it lets you store a lookup table inside the template and return values based on those keys. By the way, if you're preparing for the AWS Solutions Architect Associate exam, CloudFormation is just one small part of what real solution architects actually do. In the full architect path I've linked below, you don't just watch videos. You build 3 real-world capstone architecture projects. You get access to a monthly live Q&A with me as your instructor, and you also get a complimentary 30-minute career guidance session to map out your next steps. If you want to move beyond just passing the exam and start thinking like an architect, it's all in the description. Click on the link below and enroll now. I'll see you folks in the next step.